morning, everyone. So just want to introduce Doug, who's going to be speaking to us about modern image delivery techniques. Let's give him a warm up.
Thanks very much. Can you guys all hear me all right? Is this coming through the speaker? Do I need to go closer? All right. Maybe I can raise it up rather than leaning over. All right. Well, I'll speak loudly too, so hopefully you all hear me. Again, I'm Doug Sillars. I'm happy to be here. I'm going to talk about delivering images on your web pages, on your native apps. I mostly talk about mobile because I love working in the mobile space. Really quickly, a little bit about me. I'm a freelance developer advocate. I am traveling around Europe with my family. I'm originally from Seattle, Washington, but we've been in Europe for a year. I do performance audits. I look at how to speed up websites, how to speed up native apps. I do workshops and stuff like that. I'm the only Doug Sillars on the internet, so I'm really easy to find, which is kind of convenient. And I'll be putting up my slides up on SlideShare, so I'll have the slides up later today. Before I start talking about images, I'm going to show images because that's part of the fun of all of this. But this is the cliff walk in Switzerland. And how many of you sort of get a pit in the bottom of your stomach thinking about walking across this walkway that's nailed in the side of a mountain? I see a couple hands. I see a couple. I hear a couple laughs. So yeah, it's kind of terrifying. My 6-year-old, when we did this, decided to jump the whole way, so it was rattling. It added a little bit more of the ambiance to it. Now, about a year and a half ago, 2 years ago, Ericsson did a study on how people feel about different stress responses. And they found that queuing up, getting in line for things, it makes people feel a little stressed out. They found that thinking about walking to the edge of a cliff really stressed people out. But interestingly, they found that slow mobile websites stress people out even more than going onto the edge of a cliff. So if you're building a website or you're building an app and it's slow, that feeling you felt about a minute and a half ago is what your customers are feeling. And that's bad. And why is that bad? Well, Google found that a 3-second delay causes 53% of people to abandon mobile websites. So you're losing half of your audience. Another study found that adding a half a second delay made customers frustrated and less engaged. Walmart and Amazon both independently found that 100 milliseconds causes 1% loss in revenue. So if you're looking to make money on the web, that's kind of an important thing to do. And then my favorite one is, of course, 4% of mobile users admit to throwing their phones when something is slow. So if you see someone with a broken phone, it might be because your app or your website is too slow. So what can we do to speed up content to mobile devices? If we look at the HTTP archive, and the HTTP archive is a tool that every 2 weeks scans, it's now 1.2 million websites, and gives you data on what's there. And if you look at the average website, images are half of the content. So if we can make images smaller, they're going to get delivered faster to a mobile device, and it's going to look, and the page will load faster. So how many people here have used web page test to test a web page? I see a few hands. It's a great, awesome tool. They're set up all around the world, so you can test how your web page loads all around the world. You can change the speed, so you can see what your web page looks like on Edge. That's important. I spent a month in West Cork, Ireland, and my Airbnb said it has Wi-Fi, but it was connected to a 3G router on Edge. So while the Airbnb post wasn't incorrect, it wasn't fast. So it's very important to see what your web pages look like because the web sort of worked, but I was really patient and I had to figure out what pages I really wanted to go to. Now inside Web Page Test, there's a tool called Lighthouse, which is also in Chrome DevTools. It audits your website on mobile and gives you suggestions on how to improve your websites. Now what's really cool is the HTTP archive is built on Web Page Test. And so all of those runs that are the 1.2 million sites that are tested every 2 weeks, they run web page tests and you get Lighthouse results. And they're all up in Google BigQuery, so you can run SQL queries and get all this information out about what is on the web today. And so what I did is inside Lighthouse, there are 4 image optimizations. Those optimizations are image quality, image format, sizing of images, and lazy loading. And Lighthouse gives you a grade between 0 and 100. 0 is bad, 100 is good, right? And so let's look to see what's out there on the web today. Now, I did this analysis when HTTP Archive was just 500,000 websites. That's still a lot of websites, so we'll just go with that data. Let's talk about image quality. On my Mac, if I have an image and I start changing the quality slider to a lower value, you can see, maybe you can see, that the file size is getting smaller. And that's great, right? Smaller files are going to download faster, but as you reduce the quality, you're removing pixel information. So the images aren't going to look as good. So we want to find the balance. Where's the right place for image quality to be served on the web? So Lighthouse's recommendation is 85% quality. That's a little tricky because every single image processing tool has a different range on the percentages. So 85% in Photoshop does not mean 85% in your other tools. But let's just go with 85% and say that's great. In ImageMagick, you can set it that way. If you use a cloud-based tool like Cloudinary, you just change the URL and it generates a quality 85 image for you. Now, if we look at what's in the HTTP archive, 1/3 of websites on the internet fail this completely. So there's a huge room for improvement there, right? 43% are doing it right, but a full third are getting a 0. Now, if we look at those sites that get a 0, we load them up on 3G, the median site, so the 50th percentile, would be 2.8 seconds faster and save about 420 kilobytes. All right, so imagine just doing one optimization and shaving off 2.8 seconds off the load time of your web page. That's a pretty quick and easy fix to make your web page faster. What does this look like? Well, here's a picture I took on Friday. That's Cardiff Castle for those who I got a chance to walk around. It's really cool. That image was 1.8 megabytes. That's just straight off my phone. If I save it at 85%, I just shaved off 50%, right? It's now 900K. It's not quite 50%, but it's pretty close to 50%. But what if we want to go smaller? Like, that's great. That's an image. No one's going to be able to tell the difference. But maybe we can go a little smaller. So if we look at 50%, wow, and now it's under 400 kilobytes. That's pretty good. But if you start looking at the clouds really carefully, there's a lot of pixelization. It doesn't look very great. If we go down to 20%, you probably can't see it on this projector, but there's a lot of rasterization and ugly stuff in the clouds. You wouldn't want to put this one up on your website, even though it's just 200 kilobytes. So we know that just by following the Lighthouse example, we shave off about half of the data. The file is half the size, and it's going to download faster. We know that one looks really bad down at 20%. Well, you couldn't tell from this projector, but trust me, it was. But in between there's probably still more optimization that we can do. And luckily, there are tools out there that will let us go better than just like 85% is kind of good for everything. And those tools are called Booter Augli from Google and Structural Similarity, and there's lots of tools that implement these algorithms. And what it does is it finds the region where the human eye can't tell a difference. So it lowers the quality until the human eye can't tell a difference. And we can do that with math, which is really cool. I guess you say maths. I'll say it right. I'm sorry. I'm really, really trying. And so if I do that, it was 983 kilobytes when it was at 85%. I shaved off another 113 kilobytes. That's not an insignificant amount of data. If you look at it on the chart, it doesn't look that big, but it really is 113 kilobytes. It's going to download a lot faster. We can run these in web page tests and see what the difference is. So at 100%, it's 1.9 megabytes. It took 11.8 seconds to download. I'm using a Motorola G4 in Virginia. They actually have real devices in web page test on a 3G connection. But if I get it down to auto, it's twice as fast. So that's pretty cool, right? We've made this image load twice as fast. Let's talk a little bit about image formats. All of the images I've shown you so far are JPEGs. JPEGs have been around since the 90s. They're awesome. Everyone supports JPEG. That's great. But there are a lot of different image formats out there. These are the average sizes of a bunch of different image formats from the HTTP archive. Let's talk SVGs for a second. Vector graphics, they're really awesome. They're images drawn as shapes, so that's the Twitter logo. And they're infinitely scalable because they're vectors. So you can make it any size you want, and there's never any pixelization. It always looks great. If you see pixelization here, it's because PowerPoint doesn't support SVGs, so I had to paste in JPEGs of the... All right, so they're really, really great unless you screw them up. And so I found this logo on a website in Brazil. You may recognize the logo. It's a popular social media company, right? And they built an SVG. And because it's a vector graphic, I can open it up in my favorite text editor, right? And I've enlarged the bottom bit of this because there's this thing that says Adobe Illustrator, and then there's all this like metadata stuff. And unfortunately, when you create an SVG in Adobe Illustrator, the original file was 1.3 megabytes live on the internet. And when I went in and removed all the Adobe Illustrator cruft, basically, it was under a kilobyte. So that's like 99.9 something percent garbage, right? This website actually had 5 SVGs that they built incorrectly and then put online. So I guess the moral to that story is test, right? They did the right thing. They created the SVGs, put them online, and then had 5 megabytes of these things that should have been like under 2 kilobytes. And then, of course, because it's a text file, you can gzip it, or you can use Brotli for text compression and get it like to under half a kilobyte. But let's talk about raster images we're used to talking about. And if we look at WebP, the average WebP is about half the size of the JPEG. And WebPs are really easy to create. You can create them with most of the tools that are out there. And when I create a WebP of the castle picture, I shave off another 300 kilobytes. And that's really, really awesome, right? This image still looks great. No one can tell that I've done any manipulation to it, but I've made it, the original was 1.8 megabytes, and now it's 0.5. So that's pretty huge. If you put this up on the web, you would, with your picture tag, you serve the WebP first. If the browser can't handle a WebP, it'll fall back to the JPEG. And if we look, we shaved off another 1.5 seconds load time, which is really, really great. But you might be saying, well, WebP, that's a new format. It's from Google. It's a few years old. And where's it supported? And currently today, it's a Google format. It's supported in Chrome, and it's supported on Android. And that's not so great. But over the summer, if you look at the notes on Can I Use, it's really changed a lot. It's in development for MS Edge, and Safari and Firefox are looking at supporting it. They're experimenting with it. So it could be by the end of the year, WebP is in all of our major browsers. And that would be a huge push to help WebP, to move to a new format. Now, if we go back to the HTTP archive in Lighthouse, we see that 2/3 of the internet are not using alternative formats. They're just using JPEGs. And, as I showed with that one image, there's a huge potential for savings. If we look at all of those sites that don't use it, we're looking at 4.1 seconds faster on a 3G connection for the median page, the 50th percentile, and about 600 kilobytes less data. So by going to these alternative formats, there's a huge potential to speeding up the delivery of images and therefore speeding up your web page. The last one I want to talk about, number 3, about specific images, is image sizing. And so here's this image of a church that I took, and it was 1.6 megabytes. I did all the stuff I've talked about for the first few minutes here, and I made it half the size, right? And now it's 804 kilobytes, and that's awesome. But if we look at the dimensions, it's still a 12, 13 megapixel image, which is really, really large. If I try to load that onto a mobile phone, I download 13 million pixels, right? And then I throw away 12.5 million pixels to show it up on the screen. So on a low-powered device, you're downloading all of it, the CPU has to fire up and throw away 95% of the data. And that can actually really heat up the phone because the battery's being, you're drawing power to run the battery. And the best analogy I can think of here is when you order something from Amazon and it comes in a giant box and there's like 15 yards of brown paper that you have to go through and you're like, oh, my kid ordered a pencil, right? That's what we're doing with images on the web today, and we shouldn't be doing that. Now, it's a little tricky because these are all of the each one of these boxes is a distinct device, Android device that hit Akamai's servers. The size of the box is how many of each device hit it. So on the left, those are all Samsung S8s and S7s. The color is the speed of the processor. So the green ones are fast. All of the really slow ones are over here to the right. There are not a lot of them as you hit the Android event horizon in the bottom right-hand corner. There's 6,600 devices here. How do you resize images for 6,600 devices? It's not something you can do the exact size image for every device because that's just crazy. But what people do is they use responsive images. And so one technique to responsive images is you generate a set of images that are 25 kilobytes different in size. And so the idea there is if they're all 25 kilobytes different, the most amount of data you can waste is 25K. That's pretty good. So what I did is I took this image of the church, I generated a bunch of responsive images, and now I'm only throwing away 100,000 pixels as opposed to 12.4 or whatever it was before. There are a lot of great tools that will help you do this. This is one that's up on GitHub, responsive breakpoints. I set a bunch of resolutions, how far apart I want them to be, how many images, and it generates all those images for me, and you get a web page that looks like this, right? So for different widths, you just give a different size image. Now, code is great, but live demos are better, so let's go to a live demo. All right, so this is the web page. Picture, as I resize this screen, it's going to download the right size image for that screen, and so you can see that a new image is downloaded. Every other image is sepia and then color, so you can see when it switches. So if I make this smaller, there are a lot of changes here with really big images because really big images have a lot of pixels. But you can see on the smallest device, you're going to get a really small image. This one I think is like 25 kilobytes. Yeah, it's 28 kilobytes, and it's a JPEG, so I didn't even go down to WebP. And then that's as big as I can get it with this projector, and this one is, 81. I think the largest one is like 300 if I have a really, really big screen. But the idea here is I have a different bunch of images generated for the right size screen so I don't waste any data. And you can actually see if you look really carefully, I'm doing that with parameters in this cloud hosting site. It's called Cloudinary. And I can change the width just through URL parameters. And I can add the sepia parameter as well. So it's all generated on the fly, which is kind of fun. So what happens when I do that? Well, if I go back to that picture of Cardiff Castle, when I load it as a responsive image on a mobile device, it's no longer whatever it was, 13 megapixels. It's appropriate size for the Motorola G4 I'm testing on. It goes from 500 kilobytes to 52 kilobytes. And the load time is twice as fast, from 5,300 milliseconds to 2,800 milliseconds. So we're really, really speeding up the delivery of this content. From the very beginning, the original image, 12 seconds to under 3. Now, you can do really cool things like have WebPs in all those different sizes, and then JPEGs, so you can do the correct fallback. So the WebP customers get a responsive WebP image, and then if the browser can't handle that, you get the JPEGs. I have this thing on client hints, but client hints have been turned off in Chrome, so I'm just going to skip that slide. There's some privacy issues there that they're working out on, because the idea of client hints is that you can report the size of your viewport to the server, but if they know your IP and your viewport, there's concerns that they can figure out who you are getting around things like GDPR, so they've disabled it for now. Hopefully it will be back soon, because that's a really great way. If the browser can tell you exactly which image to deliver from the server, that's going to be really convenient, because then you're going to deliver the exact size image that you need. Now, responsive images, according to HTTP Archive, are pretty well implemented. I think this is mobile first. I think everyone decided mobile first will resize images. Almost 60% of the web is doing it, but 22% are failing. That 22% that's failing would be the median site will be 2.7 seconds faster and 400K lighter. So that's really huge, right? All of these three optimizations that I've shown so far will speed up the delivery of the content on your pages. Now, those three optimizations I've shown, yeah, 5 minutes. Oh, awesome, great. thought it was a question. I'm getting totally confused. All right, so what I've shown you so far is great for a web page that has one image, but some web pages have 2 images. Some even have 3 or 4. And so lazy loading is another technique that you can use to speed up the content. A recent study found that 57% of people don't scroll beyond the first viewport of a web page. They don't scroll down to see the stuff below the fold of the page. So if you have a web page that looks like this, where there's 4 images that the customer never sees if they don't scroll, why not just not load them until they scroll until they get to that point? We see that most sites don't do lazy loading. 60% are not doing it. They would save 3 seconds, 3.5 seconds in load time. So how do you do this? You've seen this on a lot of different sites. If you go to Google image search and look for cats in costume, you see there's placeholder images that are just full color images that represent the images of the cats on the right. You can do it with SVGs. So this is an SVG representation of the waterfalls. So you can set up preview images. That's really cool. And when you do that, the page loads a lot faster because you're not loading the images that are below the fold. If you know, the fastest code is the code that you never run. The fastest download is the download you never make. So by doing preview images and lazy loading, you can really speed up the delivery of your content. This is now available in Chrome Canary behind a flag. It's experimental. You won't even need to use JavaScript soon in Chrome. It will just lazy load all of the images below the fold automatically, speeding up the delivery of the content that your customers see when your page loads. So let's, grand summary of all of this. Look at all the optimizations of those 500,000 sites I looked at. Basically 30% of the web doesn't get 100% score on any 4 of these tests, right? There's a huge opportunity for a performance improvement. Another 30% only passes 1 of them. But what we really want to look at, these are the sites that are going to be fast, right? There's probably about 30% there as well. And these sites are going to be super fast and deliver content quickly. I've got a couple minutes left. I'm going to talk about animated GIFs really, really quickly. This is my goat, Nora. And I think we need more goat GIFs on the internet. And so I made it into a GIF, and that's awesome. The problem is the original video is 1.4 megabytes. The animated GIF is 3.8 megabytes. And the reason for that is there's no compression through time in animated GIFs. GIFs are from the 80s, and so it's really just a flip book of static images. And so if I actually take that GIF, I make it 256 colors because it was the 80s, right? It's now 250 kilobytes, and that's awesome. I can make it in a video tag, right? Loop, autoplay, muted. You have to say muted on mobile browsers so that when you're in a meeting and you're browsing the internet, the video doesn't blast and people know that you're surfing the internet during a meeting. That's why it's there. Video isn't preloaded. It's the last thing to download, so that can be a problem if you want that animated GIF that's really a movie to load. In Safari, you can actually put MP4s in the picture tag, which is really, really cool. So you can loop that Go video and then fall back to the animated GIF if the browser doesn't support that. And so for your iOS customers or people using Safari, you can see that loading that video takes 4 seconds as opposed to 22 seconds for the animated GIF. So that's a huge improvement. 3.8 megabytes to 250K. That's pretty crazy. So there are a lot of really great ways that you can speed up the delivery of images in a way that your customers won't even know that it's lower quality, but they get delivered really, really fast. So here are a bunch of the tools that I use. I use Web Page Test, HTTP Archive, a bunch of the tools I use to optimize the images. There are a lot of them out there. And I think I have 30 seconds. So if you guys want to talk, have any questions, I'll be around as well after the talk. So images can be beautiful and fast. Thanks so much.
Yeah, we're out of time, I'm afraid.
Okay.
So do approach Doug afterwards, and let's thank him once again for a fantastic talk.
Thank you very much.